So we'll wait for another 5 minutes or so. So how far with your own project? Oh, okay, directly. Okay.
Okay.
Okay, good, good. All right. Hello, Dr. Muta. You're welcome.
Hey, my dear.
Yeah, you.
Yes, my work.
My voice is cracky today.
Yes, na Kaduna Hamatan, which one?
I don't understand, bros. Yeah, Amatan seems to be going, but I came out suddenly, and I don't know. I was probably caught up.
You need chicken leg pepper soup.
Really? Okay. I think I'll get that. Dr. Mustafa, you're welcome on board. How are you today?
Hello, everyone. Yeah, thanks.
Oh, good, good, good. So sorry, guys, my voice is a bit cranky today. So maybe I will not be speaking for long. So maybe today's class will be.
You can postpone it.
Okay, maybe we have to do some voting. How many people want us to postpone? Yeah. Anyway, we'll make it very short so that you guys have time to work on your project. I think maybe that would be a good way to do it.
You know, the issue is why I hear my voice. What? Oh, 1 minute.
Sorry?
I said to you the issue is if we are like I mean long time ago where have commitments.
Okay. What about Dr. Bruno? Are you?
Let me message him.
Do you know if he's joining?
Yes. Hello? Hello?
He's joining.
Okay, good. All right. So we'll just wait for him then a bit. So, hello, Dr. Bruno. You're welcome on board.
Hello?
Dr. Bruno, he looks very tired.
Your mic. Your mic.
Thank you, sir. What's wrong with your voice?
I don't know. They say Samatan or something.
Huh?
Hopefully not COVID.
No. I think they've forgotten about COVID in Nigeria.
Yeah.
Oh, how about Malaysia? Is there still COVID?
Not really.
Yeah, there is COVID,
Okay,
but people don't care.
anymore. Wow.
Tell
Okay. All right. So welcome everyone. I think maybe we'll just go straight into what we have today. So today's class um, will not be long because we want to focus on deploying our projects, right? So and also because of my voice, a bit cranky. So maybe we'll make it a bit short. Then we have more time to work on the project. Okay. So um, after the last class, the exercise was to work on your platform and see what you want to add. So if you can see the platform I have here, um, I've added more things. So let's say for the IoT farm, right? So I'm going to be monitoring the atmospheric temperature, the humidity, the soil sensor, and the EC sensor. So the reason why there's an EC sensor as electroconductivity sensor um, is when the fertilizer in A and B is poured in the mixer. There's a mixer tank. So these are tanks, tank A, B, C, and D. Tank A is for fertilizer A, tank B is fertilizer B, tank C is for water, and tank D is for the mixture. So the mixture contains water, fertilizer A and B. So when the fertilizer A and B are being poured into the water, there's supposed to be some mixing going on here. When the mixing is going on, the EC sensor will be in the mixer, in the mixer tank. So when it gets to a certain level, then it will stop fertilizer A and B. So that's how to check the amount of quantity of fertilizers in your water. Otherwise, it might be too much. So that's why there's an EC sensor. Okay. Then, in addition, in terms of data analysis, so for this IoT smart farm, right, you want to know how much water you are consuming, either per day or per month. Okay. You want to know the amount of fertilizers you've consumed, maybe also for a month or per day. Fertilizer B, water, then the mixture. I call it mixture, but normally it's called fertigation because fertigation is a mixture of water and fertilizers that's been sent to the farm. Okay, so this is so this will help me select on this graph if I want to visualize the amount of water I've used. Then I can just select from this graph any of these parameters. So again, let's say for your project, you're supposed to know what are the data you want to visualize over time. Okay. Yeah. Then in addition, there's a control button here, which is the irrigation button. Okay. So for this irrigation button, if I press it, I've implemented the irrigation pump. If I press it, it shows me pump is on. If I press it, pump is off. Okay, this is a toggle switch that I implemented here. Let's say I may add other things like a stop button. So the stop button would be to stop the whole system, not just irrigation. So these are possible things I can add. So again, the platform is under development, right? So for your own project, right? Maybe for today, maybe we can look at some of the projects you are working on. Let's say you are working on IoT for smart homes. So what are the parameters you want to measure? And maybe we can add some things to it. Okay. For this, I can send you the whole code for this. So I see, maybe I will explain how all of this works in a few minutes. I will explain how this works on the code and how I did it. Then maybe we make the class open. Then maybe if somebody else wants to show us his own platform and he wants to implement one or two things for the class today, then we can do it together. maybe add one or two things and see how it works. Okay. So let me share the code with us. Okay, so this is the code. So basically, it's still the same modules we're importing. Remember from last class, we need to import Dash, and we also need to import Dash Bootstrap components. So these are the two key things we are importing to be able to develop our web application. So Dash and Dash Bootstraps. So the Dash is the original framework to design your web application or your dashboard. But if you design just using Dash, then if somebody views your application from a mobile phone or from a small screen, the whole thing will be scattered, will not be properly arranged. So that's why they introduce what they call bootstrapping. So Dash now introduced their own Dash Bootstrap components. Okay. Then this plot list can be used to plot graphs and all of that, but we haven't used this so far. Then we imported Dash _ DAG because we want to use some specific components like the gauge, the buttons. So there's some unique components that they developed in Dash that you can use in your dashboard that is not common to normal website. So you can get that from Dash _ DAG. That's why we imported this. Then I think all of these are just more of other Dash modules. Okay. Like this one is used for figure, to design our figures. Okay. So this is for MQTT protocol. So remember from this slide, if I show you this slide in a minute, this slide. So our design, the design is, let me see, okay. So remember from our last class, we talked about designing our dashboard, right? So you have to design the grid layout, add components, add callbacks. Then we had the internet protocol that enables us to communicate with our hardware from anywhere. So for this internet protocol, we use what they call MQTT protocol. So we'll not do that today. Today we'll just focus on these three. We try and improve more on these three things, because once our dashboard is already up to date, then we can just implement this quickly. So that is for the internet protocol. We use MQTT. So we won't do that. So I've added some of the codes for the internet protocol just for me to test. I was trying to test the button as the callback for my irrigation button that I showed earlier on. Okay, so far, all these are for the internet protocol, so I'll not talk about that now. So the first thing, like I mentioned last week, if you want to start your application, after you've imported your modules, the next thing is to create an object of your application using Dash. So you just use this code. Once that is done, once you've created your object, the next thing is for you to do your grid layout. So for the grid layout, if you remember, I said we have our container, which is our DBC container, which wraps all the web application, everything, our rows, our components, our columns, everything is wrapped in this DBC container. Then in this container, we have rows. So we start by creating rows. So first thing is to create your grid into rows. How many rows do you want to have? Depends on how you want to design your web application. So for this row 1, we just use it as our header to display the title of our web app. Okay. Then we added a what we call an header, just to demarcate the title of the platform and the other parts of the rest of the platform. So the next thing is to create row 2, which we did last week. We created row 2. So if you look at the beginning of row 2, it's from this point to sorry, I think I've missed it. Yeah, to this point. So you can know the beginning of your row and end of your row. Row 3 to this point. Then I added a breaker just to separate my third row from my fourth row. Then the next is fourth row. So under fourth row, I added the indicators. So those indicators you saw on the platform, these indicators, these are indicators which I added. So I put them on the fourth row. Okay. Then I added a breaker to separate the fourth and the fifth row as well. Then the fifth row is where I added the what they call the drop-down menu. I added the drop-down menu. I also added a graph, as this graph. So these are on the fifth row, these two components, the drop-down menu and the graph, okay? Then on the sixth row, that's why I added the toggle switch, okay? This toggle switch. So I'm going to add some more things on this sixth row. Maybe I will add the power button to switch off the whole system. Let's say there's an emergency somewhere, I can just switch on the whole system so that everything stops working. All right, so this, the IoT smartphone that I've worked on. So after all the design, the IoT platform, the next thing I would do is I would integrate the hardware to this platform. So last week, I showed us how to implement the callback. So we did the callback for just these 3 gauges from last week. So for the callback, so after you've added your app layout, your DBC container, everything is done, then you need to add callbacks. So callbacks helps us to refresh our web application on our dashboard. So in the event that there's an update, either in terms of new data or you want to refresh your website or whatever, so it helps to implement the updates and helps to refresh our dashboard. So we implemented for 3 gauges last week, my temperature gauge, my humidity gauge, and my sensor gauge. So I said for every callback, a callback is more like a decorator in programming. So you need to add whatever function you want the callback to implement. So basically, you have 2 main things in your callback decorator. One is the output, that is what component you want to update. So in this case, we want to update 3 gauges, okay? And I said for each of your component, you must have an ID in order to implement the callback. So like, for example, our first gauge, which is my temperature gauge, if I go up here, so this first gauge I added to this row 2 as an ID. So this is the ID. So you need to copy your ID value, whatever ID value you have there, copy it. Then you put it in your output. Then the component you want to update or the property you want to update in that particular component. So in this case, we want to update our value. So you could update any of the properties. Let's say you want to update, it may be that you want to update the color or you want to update the label or you want to update the value. So in this case, we are updating the value of our gauge. So whatever value it reads from the hardware is going to be used to update the value of the gauge. So that's what we display on the dashboard in real time. Okay. So all the outputs you want to control, you have to call them using their IDs and place what value you want to update. Then one important thing that triggers the update in your output is your input. So your input again can be anything. So, but what we did in this case was we used what they call DC interval. So it kind of like create a timer for you. Let's say you want to be updating every 5 seconds, every 10 seconds, every 30 seconds. Some applications, the data only changes, every 30 minutes. So you want to update every 30 minutes. Some applications, every 1 second, you have to update. Okay. So you use what they call this interval component, so which was added. Okay. So again, the interval component must have an ID, which we created. Interval, it could be anything, you can name it anything. Then you need to specify the interval. So 1,000 means 1,000 milliseconds. So if you convert 1,000 milliseconds to second, is 5 seconds. Okay. Then this is like a counter. So as this interval, after every 5 seconds, this interval will be increasing from 0, 1, 2 to infinity. Okay. So now this is going to be, the interval is used as the input for this particular callback. So this interval component, okay, you just specify the ID. So the ID, just put it there. Then the value that is coming in as input to cause the trigger is this n intervals. So like I mentioned, after every 5 seconds, this value will be changing. So once there's a change in this value, it will trigger this callback. So if the callback is triggered, then you need to specify what should be done under the callback. That's where you create this function. Again, this function can be any name. So I put it as update gauge underscore gauge, then any intervals. Now, we created some dummy values here to update our gauge, because this is not the actual value coming from the sensors, because we've not implemented the internet protocol to get data from our sensors. So we just created a dummy value here. So to generate my dummy value, I just use random.range. So this is just to generate a random value between 1 and 50. It will assign it to this value. Then this second one, it will generate a random value between 1 and 100, assign it to this variable. The same thing happens to this third one. So the next thing is you need to create a return. The return will return all these values which you want to use to update your gauge in real time. So again, the way you arrange your output, that's how you need to arrange your return values. Otherwise, it will pass this particular parameter. If you don't arrange it accordingly, if I put value 2 here, it will take this value and pass to my first gauge. So you need to arrange your values the way accordingly. The way you've arranged your output components. Okay. So this first value will go to this first gauge. This second value will go to this second gauge, and this third value will go to this third gauge. So we're able to implement that last week. Okay. Now, what I did later on was I wanted to create my toggle switch. I added a toggle switch to control the irrigation valve. So let's say I want to switch on my irrigation valve to spray the plants with the mixture. All right. So again, I put an output here, which is the irrigation button I created, this one. So the ID is irrigation button. Then in my update, when I press the button, I want it to change the label from pump off to pump on, whatever state it is. Okay. Then there's a value here which is false. So what I did here was my output now is still, you can see I'm using the same ID, both irrigation button as my output and my input. Why? Because I'm taking the value of my input, which is the initial value is false. That is, the button is assuming a false state, that is 0. It's not on. When I press it on, it will change to true. So this is what is triggering the callback. So now if you look at it, I now created a function. So I pass in this value into my function. So I will check if the value is true, that is whatever values is here from my button. If it's true, it should declare my status to be on. Then I added my MQTT protocol because I wanted to test it with my my PicoW to control my relay. So I use the MQTT protocol there. Right. So I won't talk about this now. We'll talk about this in the next class. Then, if the value is false, okay, it should declare my status to be off. Now, it should return this statement, irrigation pump, the status either on and off. So, my callback. So that's why if you look at the pump, if I press, it's false now. You can see it says irrigation pump off. If I press this, based on the callback codes that I put there, it has changed the irrigation pump to on, and at the same time, it has sent a message to my MQTT. Let me see whether my MQTT is somewhere here. So this is just an example I'm showing here. Let me increase it when I tested it. So when I press that button, it will send this message to my MQTT server saying irrigation is on. So this message will be sent to my MQTT server, or what they call the broker. So from the broker, my PicoW will subscribe to the broker and we get the same message in real time. And when my PicoW sees irrigation is on that message, it will switch on the irrigation pump for the hardware part. Okay. So that's the summary of the updated platform. So for today's class, right, we're still going to work on our platform. If you want to adopt this as your project, it's fine. It's good. But if you can focus more on solving another problem, that would be nice. And in case you have any challenges, then we can look at it together and try to fix the challenges. But if you want to adopt this as your project, it's also fine. So what I will do now is for some of us who have a different project and you want to implement one or two things on your project, so maybe we can look at it together and see what rows needs to be added, and in the rows, how you can add other components. But before I do that, so let me show you. So all these components I had idea. It's not like I created them myself. No, I added them from the Dash website. Okay. So all these components I added. So last week I showed you how to add gauge. So if you want to add a gauge, just go to the this website. So the idea is knowing what to do. That's the most important thing. Then you try to do it. So from this website, if you remember from last week, we looked at this why we picked the gauge. So you just go to this website, copy an example. So what we did last week was to pick this particular gauge. We just copy this example and we put into our IoT platform design, and that worked. So let's say for your project, you have other things you want to add. Maybe you want to add an indicator. So this is an indicator. This is an indicator. So that's what I added. That's what I added. This is in the platform. These are the indicators I added. So these are valves, just to show me that